Have you ever wondered why an object at rest tends to stay at rest, and an object in motion tends to stay in motion? This phenomenon, often observed but seldom questioned, forms the very bedrock of our understanding of the physical world. It's all thanks to a man named Sir Isaac Newton and his 3 laws of motion. The first law, often termed as the law of inertia, states that an object will remain at rest or in uniform motion in a straight line unless acted upon by an external force. Picture a soccer ball on a field. It won't move until a player kicks it. Similarly, once the ball starts moving, it won't stop or change its direction unless another force like friction or another kick comes into play. Newton's second law of motion goes a step further, explaining how the velocity of an object changes when it's subjected to an external force. The law states that the force acting on an object is equal to the mass of that object times its acceleration. This is why it takes more effort to push a car than to push a bicycle. Even if you apply the same force, the car, having a larger mass, accelerates less than the bicycle. The third and final law of motion states that for every action, there is an equal and opposite reaction. This means that any force exerted on a body will create a force of equal magnitude, but in the opposite direction on the object that exerted the first force. So, when you jump off a boat, the force you exerted downwards propels the boat in the opposite direction. In essence, these 3 laws of motion form the basis of classical mechanics and have been used to understand and calculate the dynamics of motion in various fields, from astronomy to engineering and everything in between. To summarize, Newton's first law, the law of inertia, explains why objects stay in their current state, be it rest or motion, unless an external force acts upon them. The second law connects force, mass, and acceleration, telling us that the force on an object equals its mass times its acceleration. Lastly, the third law states that every action has an equal and opposite reaction, explaining why forces always come in pairs. These laws, though centuries old, continue to guide scientists and engineers in their daily work, helping humanity to reach new heights, from the deepest depths of the ocean to the farthest reaches of space. Understanding these laws of motion can not only help us appreciate the world around us, but also unlock the secrets of the universe.